back to my channel, and today I'm going to be talking about probability. So let's begin by talking about the definition of probability and then progress further. So what is probability itself? Probability is a chance that we'll get a specific outcome over all possible outcomes. Now we can have multiple outcomes for that specific outcome, which we'll consider later in this video. Now probability has a lot of applications. It is often associated with when we have large amounts of data. So the social sciences, which essentially collect a large amount of data and associate a specific group of people or specific type of people or amount of people with a specific characteristic or medical condition, well, then we can use probability. So probabilities is used a lot in economics, finance, medicine, social sciences, and so on and so forth. So whenever we have a large amount of data, nature, or just pure mathematics itself, we can often find probability. Okay, now let's start talking about and or probability. So what is and probability? And probability states that the probability of getting an event A and an event B is equal to the probability of getting the event A times the probability of the event B. Now over here we have if independent. We'll talk about that after we review OR probability. So what is OR probability? OR probability states that the probability of an event A or B occurring is equal to the probability of A plus the probability of B subtracted by the probability of A and B. Okay. Now let's actually start talking about the minor definitions, independent, and which we have one here, mutually exclusive, and then move on to actually calculating this. So what does an independent event mean? An independent event means that this event does not affect any other future coming event. So this event is independent of another event. So that's what an independent event means. Now when we deal with factorials and other types of probability and just regular probability problems, if we know that an event is independent or not, this is very helpful. Next we have mutually exclusive. Mutually exclusive just means that events, or some events, or two events, don't occur at the same time. Now, mutually exclusive is very important when we're dealing with OR probability because we can simplify the equation further. Now let's just talk about probability and a specific definition for all possible outcomes. When we consider all possible outcomes, we can call that a sample space. So a sample space is pretty much all of the possible outcomes that can occur. Okay, now let's continue. So if we look at OR probability, we know that if it is mutually exclusive, so if the probability of A and B, so they don't occur at the same time, and if that is mutually exclusive, which is what that means, then we can simplify this equation to get probability of A plus the probability of B. So we'll write if mutually exclusive. This is what it means. Okay. Now, you might be wondering, why did we take the subtraction of P, the probability of A and B off? Well, the reason is actually quite simple. So if we have the probability of A plus the probability of B, this is going to be our main part of the equation. The probability of A and B occurring is the probability of A and B occurring simultaneously, or just them occurring both times. Now, if we're saying that this is mutually exclusive, we know that they don't occur simultaneously. They don't occur at the same time, which means that this is obviously canceled out because since they don't occur at the same time, A and B, the probability of them both happening can't happen. So that's pretty much what OR probability is saying. Okay. Now let's look at and probability once more. So the probability of event A and an event B is equal to the probability of A times the probability of event B. Okay, so let's consider a specific problem over here. So let's consider that we have a dice. And we roll it 2 times. So what is the probability that we get a 1 and we get a 6? So what is the probability that we get a 1 and we get a 6? Well, let's first identify that if it satisfies the independent event condition. Notice that in OR probability, if it doesn't satisfy mutually exclusive, we can use the former equation. But if it does satisfy that it's mutually exclusive, then we can use the latter. However, in AND probability, we can only use this equation if it's independent. Now, there is a specific equation, but that uses conditional probability, which we'll talk about in a future video. Conditional probability states that the probability of A given B is equal to the probability of A and B all over the probability of B. Now, it uses the word given and all other things to make it a little bit more complicated, but has an important meaning in the field of probability. We'll talk about that in a later video. Okay, so now going back, we must identify that it's independent. If we roll it 2 times, we obviously know that it's independent. How? Well, if we roll a dice 1 time, then when we roll it a second time, the first time doesn't affect it. Because if, let's just say we roll let's just say we roll 1 on the first try, then we can obviously roll 1, 2, 3, 4, or 5, or 6 on the second roll. So rolling 1 previously does not affect the other roll, and same for any type of number. So it does not affect any other type. So this is independent because the first roll does not affect the second roll. So they're independent, so we can use this equation. Okay, so the probability of getting a 1 is obviously just going to be 1 over 6, because the chance of getting the outcome in this case is 1. And how much is the chance of getting 1? 1, because there's only 1 in a dice. So you have 1. And all possible outcomes, or the sample space, well, the sample space over here is 6, because we have 1, 2, 3, 4, 5, or 6. So it's 1 over 6. Now multiply that by getting a 6. Now the chance of getting a 6 is just 1 over 6. Well, the probability of getting a 6 is 1 over 6, because the chance of getting a 6 is just 1, because there's only 1 6 on the dice, and the sample space is 6. So we have 1 6 times 1 6. So 1 6 times 1 6 is equal to 1 over 36. So getting a 1 and a 6, the probability of getting 1 and a 6 is equal to 1 over 36. Okay, now let's consider OR probability. So OR probability. So let's say we have a dice, and we're going to say what's the probability of getting a 1 or a 6. Now, right now, we can obviously get a reasonable guess that this is going to be definitely bigger than the previous result. The reason is because 1 over 36 is a very, very, very small number. Now, as you can see, we're adding things here because we know, which we're going to be talking about right now, but this is mutually exclusive. Because as we can see, we're rolling this 2 times again, which means that they don't occur at the same time. They're mutually exclusive, because you can't have a dice get a 1 and a 6 on the same time. So obviously we can see that this cancels out. So if we get the probability of getting 1 or a 6, this involves the probability of 1 and a 6. But as we can see, you can't get 1 and a 6 because this is mutually exclusive. And we're rolling it 2 times. So since this is mutually exclusive, we can pretty much just go right now and start doing it. So the probability of getting a 1 is just going to be 1 over 6. And the probability of getting a 6 is also 1 over 6. So we add them to get 2 over 6, which simplifies to 1/3, or 33.3%. Okay. So let's review the steps that we did over here. So the probability of getting 1 or a 6. Now these are mutually exclusive because they don't occur at the same time. Because we're not rolling them simultaneously. We're rolling them once and then rolling them again. So they're mutually exclusive. They don't occur at the same time. If we roll them both at the same time, there's a probability that we'll get a 1 and a 6. But we're not. We're rolling the 1 first and then we're rolling the 6. So this is mutually exclusive because it doesn't occur at the same time. So we have 1/6 plus 1/6, 2/6, 1/3, which is 33.3%. Now this is obviously pretty reasonable to do because, as you can see, these are two outcomes over all possible outcomes are 6. We get 2 over 6, which is 1/3. We can easily see that if we roll it 2 times, or just take one dice, we roll that 2 times, so obviously it can't come at the same time. So obviously, this is just going to be 1/3, or 33.3%. So if we get this is not going to be 33.3% because 1/3. Now we have to multiply this by 1/12 to get 1/36. Okay. So this is simple problem of and or probability. Okay. Now let's talk about the difference between probability and odds before we end this video. Okay. So we have this over here. So let's review the difference between probability and odds. So the probability is the chance of getting the outcome over all possible outcomes, which we'll define as the denominator to be the sample space. Now, what are the odds? So let's consider a coin flip. If we consider a coin flip, the sample space is obviously going to be 2. And the chance of getting a head is 1, the chance of getting a tails is 1. So obviously, the numerator is going to be 1 over 2 no matter what. And this is equal to 50%. Now, if we consider the odds, this is different. Because it's the chance of getting the outcome over the chance of not getting the outcome. Or which I'll call the opposite outcome. So if it's in favor of you, then the denominator, so if the numerator is in favor of you, the denominator is not in favor of you. So it's the chance of getting the outcome and the chance of not getting the outcome. So the chance of getting the outcome is 1. The chance of not getting the outcome is 1 because there's a tail. So this is 1 to 1. In probability, we include the outcome itself, but in odds, we don't include the outcome. We can consider this with the dice too. So the probability of getting a 1 is going to be 1 over 6, as defined. Now the odds of getting a 1 is going to be 1, and what's the probability of not getting a 1? The probability of not getting a 1, well, not the probability, we mean the chance of not getting a 1. Well, that's 5. By chance, we're just broadly just saying that it's the amount. So by chance, right now, we're referring to amount. So we have 1 to 5. So the odds are 1 to 5, where the probability is 1 over 6. So that's the difference between odds and probability. Sometimes the discrepancies are small, but sometimes the discrepancies can be big. So it's important to know the difference. Okay, so let's review. Probability is the chance of getting an outcome over all possible outcomes. Now, we know that all possible outcomes are just going to be the sample space. So the amount of all possible outcomes is just the sample space. Then we have independent events. Independent event states that this event does not affect another event, so it's independent of the other. Then we have mutually exclusive. Mutually exclusive just means that these events don't occur simultaneously. They occur separately. That's what mutually exclusive means. Okay, now let's review and or probability. If this is an independent event in and probability, the probability of getting the event A and B is equal to the probability of A times the probability of B. Now for or probability, the probability of getting an A or a B is equal to the probability of A plus the probability of B subtracted by the probability of A and B. Now if this is mutually exclusive, then we have the probability of A plus the probability of B. So if this is mutually exclusive. Okay. Now that we've talked about and probability, or probability, and just regular property in general, we can make this video to an end. If you like this video and you like this channel, please subscribe to learn more.